Hello and welcome to our introductory module into the structure of organic compounds. So today we're going to be covering two things. So firstly, we're going to be going over the basic carbon skeleton and how to name that. And then we're going to be going over some functional groups, namely alkenes, alcohols, aldehydes, ketones, carboxylic acids, haloalkanes, esters, nitriles, amines, and amides. So it seems like a lot, but today I want you to just focus on the functional groups. So today we're just going to be covering the functional groups that you're going to come across in your chemistry studies in year 12. We'll cover naming and reactions and everything else in regards to organic compounds in separate videos. But today, just focus on the functional groups and getting familiar with them. So the first thing I want you to understand is that we actually name organic compounds based on the number of carbon atoms that are in the chain. So this is a short table that you can refer to in regards to the number of carbon atoms and what prefix they correlate to when you're actually naming them. We're going to be analyzing how to name chains just based on looking at the most simple organic compounds, and that is an alkane. And recall that an alkane is nothing but carbons linked to each other by a single bond with hydrogen surrounding. So that would be a pretty simple alkane. So, for example, if a carbon chain has 5 atoms, we would denote it with the prefix pent, and since it's an alkane, we put the suffix ane at the end. So a carbon atom with all single bonds with 5 carbons in its chain would be pentane. And in this way, we'll start there because those make sense. So 5 pentane, 6 carbons in the main chain, hexane, 7 heptane, 8 octane. So you might recall that from when you fill up petrol. So 98 octane. So that's an organic compound that's an alkane with 8 carbon atoms in its main chain. 9 nonane, 10 decane. So I want you to really remember that because you're practically going to need to memorize it. It's really high yield in regards to naming compounds. However, everything before 5 is a little less intuitive. So something with 1 carbon atom in its main chain, or that'll look something like this. So this is what we call methane. So you might have heard of methane gas. 2 carbon atoms in the main chain, we call that ethane. 3 propane, you can use that in stoves. 4 butane, so that's something that's found in lighters. And a really nice, so I like to memorize using just short sentences, and usually the weirder they are, the better they stick. So I've got my enormous panther bounced to denote meth, eth, pro, and bu as the prefixes. Look, use whatever system you'd like. That's just the one that works for me. So I like to split it up as 1 to 4 meth, eth, pro, bu. So those are the 4 you need to memorize, and then everything after that is kind of intuitive. So 5 pent, 6 hex, 7 hept, 8 oct, 9 non, and 10 dec. So now that you know how to actually name the main chain, another thing you need to be able to address is firstly identifying, and secondly being able to name different functional groups. Now you might think, what is a functional group? Essentially, a functional group is a substituent or something attached to the main chain that causes its chemical properties or reactions. Now I don't want you to actually stress on what those properties or what those reactions or changes in reaction are. For the purposes of this video, I want you to just be able to good at recognizing the different functional groups and then learning what prefix or suffix is associated with that. Over the next couple of videos, we're going to be expanding on this. So in the next video, we're going to be showing you how to actually name different compounds based on what you've learned in this video. And then we'll have a different video entirely on the different properties of different functional groups. But for the sake of this video, I want you to just focus on recognizing the functional group and that what prefix or suffix is attached. So the first one we discussed before is an alkane. So I like to group the functional, because there are a lot to memorize. I like to group them in a logical system. So I feel like the alkane, alkene, and alkyne, we can kind of group them together. So an alkane is a simple carbon chain with all single bonds. An alkene is a single carbon chain with a double bond anywhere. So there could be one or more double bonds. It doesn't mean that they all have to be double bonds. It could have one or it could have more. An alkyne is a carbon chain with one or more triple bonds between the carbons. Alkanes we denote by the suffix ane at the end. So an example of that would be ethane. An alkene we denote by the suffix ene. So an example would be ethene. And an alkyne we denote by the suffix ine. An example would be ethine. So these are the three examples we have. So that's the first one. There's ethane, which kind of makes sense because you have the carbons connected with a single bond, and there's hydrogens attached to the carbons, and that is meth. So there's two carbons. So a carbon with only one would be meth, a carbon with two would be eth, and then since it's an alkane, we add the suffix ane, so it's ethane. Same for the alkene. So we have a double bond here, so it must be an alkene. One carbon meth, two carbon eth. So thus, this molecule, with a double bond and two carbons is ethene, because we use the suffix ene. Our third example is an alkyne. So look at the triple bond we have here. Again, two carbons denoted by the prefix eth, and we put the suffix ine at the end. So this is ethine. If you want to memorize that order, that also works, but also they kind of make sense. So alkanes, ane. So think of single bond coming first with the A. Alkenes, so they have double bonds, so come next in the alphabet, E. Triple bonds come third in the alphabet, so Y. So you can remember in that order too. A haloalkane is basically an alkane with a halogen attached. So recall that the halogens are the group of periodic elements second from the right column on the periodic table. So you can have fluorine, chlorine, bromine, and iodine. So those are the most common halogens that you're going to come across. We actually denote them, a haloalkane that is, with a prefix of either fluoro, chloro, bromo, or iodo. The example we have today is fluoroethane, and I'll show you how we got that actually. So we have two carbons, so you might recall this being quite similar to that. So if we cut out the link to the F, completely forget it, do you agree that would be ethane? Seems easy enough. However, we actually have a fluorine group attached to the carbon. Thus, we add the prefix fluoro to ethane to get fluoroethane. If that fluorine group was a bromine, we would call it bromoethane. If it was a chlorine, we'd call it chloroethane, and so on and so forth. For example, if it was an ethane and it had 5 carbons, we would call it fluoropentane. Seems easy enough. The next one we have is hydroxyl or alcohol groups. I like to remember the little Q, alcohol, so it has OH in the actual name. And alcohols, you can think of are alkanes with an OH. So again, if we omit the OH group attached to the carbon, this just here is methane, ethane. So that is ethane. However, it's got this pesky OH group attached. So how would we name this? you look at the OH and you must immediately recall that that's an alcohol. And alcohols we name with the suffix anal. So thus, this would be ethanol. If it had 5 carbons in the main carbon chain with an OH attached, we would call it pentanol, and so on and so forth. So in this way, I hope you can kind of see what we're doing. So the first thing we do is we look at how many carbons are in the main chain, and then we look at the functional groups that are attached. So some, such as the alkane, alkene, and alkynes, might have no functional groups. However, some that I've introduced you to now will have some functional groups. So first you need to be good at naming the main chain. So refer back to the previous slide if you're having troubles, and then look at the functional group. Please memorize the prefix or suffix. You can also do some flashcards to reinforce this understanding. And then combining this prefix and suffix, you can get a name. Alright, so the next one we have is a carboxyl group. Essentially, a carboxyl group is like an alcohol in that it has the OH attached to the carbon, but this time it also has a double bond oxygen. And we actually denote carboxyls as with the suffix anoic acid. So we're going to look at this now. So look at the main carbon chain. It has meth, 1 carbon, and 2, another carbon. So that's, we'd obviously use the prefix F. Now look at this group. This is a carboxyl group. So thus, we call it ethanoic acid because it has a carboxyl group with 2 carbons in it. You can also kind of think of carboxyls as alcohols with that extra double bond O, just to make it easier to memorize. So the next functional group is an ester. So an ester is denoted by, it's really actually quite similar to a carboxyl group in that there is a double bonded oxygen. However, instead of the single bond being an OH, it's actually just an O. And then here you'd have 1 carbon chain, and then here you'd have another carbon chain. I don't want you to focus on too much about how to actually name an ester. Just recognize that if you see a functional group that kind of looks like that, you're going to denote it with the suffix O8. So this compound here is methyl ethanoate, and the same kind of works the other way around. So if you see methyl ethanoate, just know that it's an ester and it will have a functional group that looks like this. The next 3 we can actually kind of class together. So an amine is a nitrogenous compound, and recall that nitrogen can make up to 3 bonds. So it has 3 arms, if you will. An amine has a nitrogen or an NH2 group. So nitrogen is using 2 of its arms to bond with hydrogen and 1 of the arms to bond with a carbon chain. We're going to skip the amide and go straight to a nitrile. A nitrile compound is one in which nitrogen is using all 3 of its arms to bond with the carbon chain. So the carbon can only bond to 1 carbon group because carbon can make up to 4 bonds. So if 3 is being used to bond with nitrogen, we can only make 1 more bond, and then there could be another carbon chain here. An amide is somewhere kind of in between. So an amide has carbon double bonded with the oxygen attached to a carbon chain and the nitrile group. In all of these, you name them based on first looking at how many carbons are in the chain. So this would be 1, 2, 3, for example. This would be 1, 2, 3, and this would be 1, 2. So you name the carbon chain first, and then you look at the type of functional group. So if it has an NH2, it's an amine. If it has the C double bond O and then an NH2, it's an amide. And if it has a triple bonded nitrogen, it's a nitrile. And just remember these suffixes. So amines, anamine, amide, and amide, nitrile, just nitrile. So this obviously would be an example of 1, 2. This is an amine group, so ethanamide, 1, 2, eth, double bond oxygen, NH2, so that's an amide functional group, and it has 2 carbons, so that's ethanamide. 1, 2 has a triple bonded oxygen, so this is ethane nitrile. So the last 2 functional groups are aldehydes and ketones. They share one similarity in that they both have a C double bonded to an oxygen. The difference lies in what else is bonded though. So recall that carbon can make up to 4 bonds. If 2 of the bonds, or arms if you will, are used to bond with the oxygen, as in both groups, both groups have 2 arms left. In an aldehyde, so aldehyde with the H, you can guess, one of those arms is used to bond with a hydrogen and the other is used to bond with a carbon chain. We use the suffix anal to denote an aldehyde, and this is an example of an aldehyde. So 1, 2 carbons in the main chain. This is the aldehyde functional group, so this is ethanol. Next we have ketones. So again, we have the C double bond O, however in this case, it'll bond with carbon chains on either side, so there's no hydrogen. We use the suffix anone to signify ketones. So again, 1, 2, 3, meth, eth, pro, so this is propanone because we have the ketone group. If we were to have a hydrogen instead of the CH3, it would become an aldehyde, for example. So recall, ketones, carbon chains either side of the main functional group, aldehydes, carbon chain on one side, hydrogen on the other side. Before we go into naming, you're going to see a lot of these carbon skeleton diagrams. So it's really important you actually know what you're looking at. So this squiggly line actually signifies a carbon chain. So every kink in the skeleton, so I'm going to draw little dots to signify these kinks. So every kink in this carbon chain is actually denoting a carbon molecule. And the lines in between mean single bonds. A double bond would obviously be a double line. It's assumed, so we don't draw the H's, but it's assumed that every kink, since every kink is a carbon, there are hydrogens attached. So this carbon would have 3 hydrogens attached, and if that carbon and that carbon have a double bond, it would have 1 and 1. So everywhere where it's not, it's not shown or not connected to a carbon, you can assume there's a hydrogen there. Okay, for the last of the compounds, we're going to talk about cyclic hydrocarbons. You don't actually need to know how to name them just yet. We'll go over that in a separate video. But for your senior studies, you need to be able to draw the difference between 2 main ones. So hydrocarbons aren't always linear, so they don't always look like this. So that would be ethane. Sometimes we can write them, or they present in nature rather, as ring structures. So if you look at this ring, every kink or corner of the ring is a carbon. So 1, 2, 3, 4, 5, 6. So this is a 6-membered ring. You may recall we denoted with the suffix, or prefix rather, hex. So this is cyclohexane, signified with 1, 2, 3, 4, 5, 6 single bonds. On the other hand, we have benzene. So this is a compound you may have heard of. Yeah, actually, funnily, causes a lot of cancer in pesticides. So again, it has a 6-membered carbon ring. However, instead of all the single bonds in cyclohexane, benzene has 1, 2, 3 double bonds. You may also see benzene actually drawn like this. Just for your interest's sake, you may see that circle. All that means is these bonds can actually move about in these benzene rings and assume different positions. You don't need to know that for your chemistry studies, just for your own understanding. Just recall, benzene can either be drawn as a 6-membered ring with the 3 of its double bonds, or drawn like this, so either of those. Cyclohexane is basically, you can think of it as benzene with all single bonds. Hopefully this video was a nice introduction into all the functional groups and how to name the actual carbon skeleton. Please do some flashcards on the functional groups, and in our next video we'll be going over naming the actual carbon compounds.